Okay, then welcome to my talk about the GHC plugin to compile effectful languages as well. So in our research group here in Kiel, we have a programming language called Curry, which we often describe as being Haskell plus ambient and lazy non-determinism. And one of the compilers for this language is this GHC-2 compiler, and it has 120,000 lines of code. And a lot of the features of GHC we had to re-implement, things like type classes and higher rank types. And additionally, we also have to implement things like a parser or name resolution and a type check, of course, as well. And all of this is a lot of work, which contributes to those 120,000 lines of code. And then we thought, well, maybe we can reuse some of the implementation that GHC already has for all these features and use that implementation to, well, massively make our compiler smaller. And so we came up with the idea to use a GHC plugin to implement our Curry compiler. And this has brought down our size of the compiler to only 7,000 lines of code, in contrast to the 120,000 lines of code we started with. And we even get some of the language extensions that GHC provides basically for free. Those are language extensions like multi-parameter type classes, or even extensions like lambda case and other simple extensions. And in fact, we have actually shown that we can use the same approach to implement other languages that are similar to Haskell, but use not non-determinism as an effect, but for example, probabilism or other effects as well. And so how do we use this plugin? First, at the top of the module, of course, we have to activate our plugin by using an options pragma from GHC. And after activating this plugin, our transformation will be activated, but we also have to replace Haskell's default prelude due to compatibility problems. And for that, we import our own prelude. And using all this, we can, for example, implement a function that computes all permutations of a given input list by repeatedly inserting all elements non-deterministically. And that's what this insert function does here. It takes an element E and some list, and then it has this question mark operator here, which is a non-deterministic choice between its left and right argument. And so we insert it at each possible position in our original list. And this gives us all the permutations of our input list. And one thing to note here is that this is actually an ambient effect. So it isn't actually visible on the type level at all. Instead, it is hidden, which helps with the compositionality of this function and other functions in the context of our plugin. And this is actually how Curry, the language itself, does it as well. And one benefit we get from implementing our compiler with a plugin is that we can even embed this new language in Haskell itself by just importing the module we had before in a new module that doesn't actually activate the plugin. And here we can capture our non-deterministic computation by saying that we want to evaluate it here. This is the function we want to evaluate, and here we apply the argument for our permutation function. And this gives us exactly the permutations of our input list, of course. And we could use this result here to further do any more computations on it, like looking up the length of this list or something else. And so the implementation of this plugin actually consists of 3 sub-plugins. We extend after the renaming phase in GHC, after the type checking phase, and we also extend GHC with a constraint solver plugin. And in our import check here, after the renamer, we only check that any module that is being imported is actually compatible with our plugin, so that a user cannot import modules that are written in basically plain Haskell and not were activated with our plugin. Then we have this constraint solver plugin, which mostly helps in making the effect ambient by hiding our effect type from the GHC type checker. And the meat of our transformation takes place in this lifting phase, where we actually have to lift all functions and data types in a given module. And that's what I want to talk about a little bit more. If we take, for example, the definition of Haskell's built-in list data type, and our transformation is a basic monadic transformation. So we wrap every argument to each constructor in this F monad, which is our effect monad. And this allows us to actually have a nested effect inside of our data types, nested arbitrarily deep. And one thing we have to make sure of is that we actually have to replace each type constructor with a lifted version. This is also true for the function arrow type constructor in Haskell, which we actually replace with our own function arrow that you can see here. And I've already said it, we also have to lift functions. So let's look at that. If we take, for example, this repeat function here, which creates an infinite list of a given value, we can use an ordinary monadic transformation to get our lifted function, but we have to watch out, because this x value here, our argument, is now actually turned into a monadic computation, and we don't want to execute any effects in this x here multiple times. And so we have to make sure to explicitly share this x computation with a share operator that is provided by a library from Fisher et al. And using this operator, we make sure that this new x we have here on the right side is basically effect-free, so that our lifted function doesn't execute any effects multiple times. In the context of non-determinism, this would mean that we actually share any choices that were made in the computation of x across both occurrences here in cons and the recursive execution of repeat f. So there are two further future works that we want to take care of in the future. And the first one is that we want to generalize our plugin, as I've said before, not to work with only non-determinism, but that the user can basically plug in his own effect into the plugin, so that we can combine GHC with our plugin and an effect to create a compiler for another new language without having to basically fork the whole project, because currently our effect is actually hard-coded, but the whole transformation is completely orthogonal to the effect that we are using. So there's not actually a reason to keep it hard-coded, it's just harder to implement. And the other thing we want to explore is the interaction between our plugin and GHC's extensions, mainly the extensions to its type system. With the new GHC, we have extensions like linear types, or we have older extensions like type families, and we haven't actually looked at those extensions in the context of our plugin. We will probably have to adapt our lifting a little bit, and that's one of the things we actually want to do in the future, because currently the extensions that are working are mostly related to either syntactical extensions like lambda case, for example, And also extensions related to type classes are working as well, multi-parameter type classes and functional dependencies, for example. And that's all I wanted to say.
Okay, thank you. There is one question on Cloudar from Andre. So,
yeah, can you hear me?
yes.
Yes.
So I was wondering mostly about the interactions with the module system. So I mean, first of all, I should say it's a great talk. Thank you. Do you have any problems if you're doing this type level lifting operation and you have things interacting coming from different Haskell modules that you have to do some sort of reverse translation? Or can you just recognize by the occurrences of shareable and F that these are lifted types and it all works out?
So that's a great question. That's basically the main thing in our implementation that we have to look out for. And because our transformation takes place after the type checker, the types that we write into the import tiles, the module files are actually transformed already. So we have to make sure that if we import those definitions, that GHC can still type check these new programs. And that's what the constraint solver plugin is there for. The constraint solver plugin takes care of removing the lifted type, basically, and we don't have to actually insert any new information into the interface files. We have everything we need already.
Okay, thank you.
Okay, next, Matthias.
Yeah, so I was wondering, did you have any issues kind of communicating between phases within the plugin?
So we don't actually need to communicate between the phases of our plugins. That's one of the nice things in our implementation. So no, we don't have any problems there.
Okay.
Okay.
I have also a question.
Yeah.
So basically, once you make it user configurable, which effects you want to use, it starts becoming a kind of a real effect system where you can define your own handlers and such. So I was wondering how does this compare to other languages that have a real effect system built in, such as Frank, for example?
So maybe those languages normally take it a step further. We only want to basically, when the user invokes the plugin, he would specify which module contains the effect that he wants to use, and then our plugin would use the effect found in that module for our transformation. That's at least what we're planning for. So I think we are not that far.
Right, so it's a little less flexible, but in exchange you get the whole GHC ecosystem. Okay.
Okay.
Are we asking questions in the order the hands are raised? I thought I raised my hand before anyone
I'm
else.
sorry.
I
was
not a problem at all. I was just checking.
Yeah, go ahead.
Very interesting work. But the question is, what actually happened to the types and what happens to type safety? Now, Kai, if you go back to the slide with eval1 DFS. So what happens when you drop eval1 DFS? In other words, suppose you just print permutations. What is that a type error?
That will be a type error because in this module here, after importing, permutations will have this lifted type, which includes this F monad, and you can't just print that out even after you cannot actually apply it to a list that easily. So this is still type safe.
Yeah, yes, but the thing is that the programming becomes a little bit more interesting, because on the one hand, presumably when you query the type in the REPL, it says it's still a list, but it is a lifted list. This is like a tacitly lifted list. You realize, right? So you know.
Yeah. So if you query
you
the
can't
type
pass it to a list receiving function, you know.
Yeah. So if you query the type of permutations currently, you will get the lifted type. So yeah. The only thing is that if you use this permutation function in another module where you've activated the plugin, GHC will type check it as if it wouldn't be lifted. So only in a plugin, only in a module where the plugin is activated, this type is invisible. In every other module, it is still lifted. Okay,
one more question. If you go to the slide with the F monad, now here, I noticed that nil is not embedded in F. In other words, is that a typo, or is that really what it is? The nil constructor.
So you mean the nil here?
The nil constructor. Yes. Data list FA is just nil, but it's const FA. Whereas it looks to me that it should be F of nil.
Yes, so you can't actually define such a data type in, so the nil is the name of the constructor, and the type of nil is list f of a, and you can't define a data type in GHC where the result of your constructor is something different than what you declared here in your type constructor in normal data type definitions. And actually the lifting you think that should be there is hidden in this new function arrow, because here we have this f that you might have expected in the data type definition.
So nil is a bit more like an f nil, is it? Because the last time I looked at this, I'm referring to the Atke and Johan paper on interleaving data and effects. I'm almost sure that, you know, even the nil constructor of the list is actually sort of wrapped, so to speak, to use the current language, in the monad. So it is not, you know.
So it might be a great idea to take this question offline, because we are already over time.
Sure.
So
okay.
Just shoot me a message.
Yes.
Yeah. I see that Rushil has another question, but since we're running out of time, please write down your question in the text chat so that Kai can answer later. Thank you. Okay. Thank you, Kai, for the nice talk.